Hello, I'm going to talk about Mantis Shrimp, a tool I made some time ago to compute the differences between images. That was the main purpose of it, but it evolved into something bigger because it's kind of like a shader toy, but instead of using GLSL or HLSL, it uses a metal shading language. So I'm gonna talk about how it works first, and we'll give some examples, and then I'll talk about metal shaders a bit and how you can write metal shaders within Mantis Shrimp. And then I'll go and show you the inner workings, how Mantis Shrimp is programmed. It's made in Swift and in Xcode with Metal SDK. So let's start. So you can read the details here, or in the web page of Mantis Shrimp, or in the App Store, or whatever. There's a manual, but I'll show you directly. Well, the first thing is that Mantis Shrimp is a document-based app, so you can open these documents, which are called .mantis Shrimp files, and you can open as many as you want. You can open several of these. Let's focus on this example here first. You can drag and drop two images here, and then it computes the difference, but the difference is computed with a bit of shader code. So the shader code samples the texture, and then here it just computes the absolute difference between those two colors. You can compute this in linear or in sRGB. So in linear space, it looks like this. This is in sRGB. You can also do use some other presets. So I have here the perceived lightness. As I say, I use this for different purposes, but and also you have a bar here, so you can use this as some parameter, which is called uni.scale. Well, you can read the manual about how that works. I also have this. Anyway, so this is the basic usage. But since I made this tool and you could write shaders and compile them here in real time, I thought, why don't I use this, pass the time, a time parameter, and do something like shader toy? And that's why I have this weird stuff in here going on. You can see examples of how this works, but it's if you are familiar with shader toy, something similar. I pass the time in this uniform buffer called I just call it uni.time, and then I have several examples here. Cloud shapes. This is something I ported from shader toy, and this is a fragment shader. So basically I have the signature here, but this is something I created. The actual signature is different. So one of the things I use this tool for is to help me create figures for blog posts and stuff. So this is an example where I'm shading a sphere with Lambert. So Lambert is just the color divided by pi, so not very interesting. But how is this a sphere if this is a fragment shader? How the sphere works? Well, this is very simple. So I basically, because you have the UVs, I'll debug here. Okay, so these are my UV coordinates, right? Then I duplicate the UV, so I have 4 in this case. So these are my duplicated and centered UV coordinates, and so 0, 0 is the origin at each square. And then I compute the normal. The normal is just I compute Z with this, right? And then I just have a value that is 1 on the surface, so that's my normal. And then I have the four areas, so I can compute the index with the 4 areas. I use this index to compute a different color for the sphere. And then because I have the normal, I can compute .nl, and then I can generate a light. The light is simply at the top of each sphere, rotating with a sine and cosine of the time. And then I specify a cycle time, which is the time I want it to cycle. I could pass this as a parameter, but I didn't implement that. But anyway, I hard-coded this. The cycle time here is the same time as my video. Because you can record a video, you can change the frames per second and then click record and then save this in a folder. And now I have a 2-second video which should appear in my movies folder, and that's my video. So now I have a figure. Why do I have this figure? Well, it's because I'm writing blog posts. For those blog posts I can use embed MP4s. The MP4s are just a few kilobytes. I don't know how big this is. 400 kilobytes, not that big. And then I embed them, and instead of having a boring image, I have a rotating image with different lights. And these are different examples. Lambert shading, font shading, other tests. This is the Smith visibility function. This is something else I was doing. Radial stripes. Well, anyway, so this is why I have this functionality to record videos. The other thing I had is that I was creating programmer art. So I recorded videos for the Genuary. I don't know if you've used that Genuary prompt thing. I have the lava lamp example. What else? I have some funny kiwi. Anyway, this is from January last year. I haven't done January this year, but you can find all the examples in GitHub in Mantis Shrimp examples. Fine. In January 2024, I haven't done anything else. This is the typical Mandelbrot. So you can see it's all C++. It has some special vector types which are called float2, float3, float4, half4, etc. Apart from that, I think it's quite straightforward. Interestingly, this is for the fragment shader, as I said, but I also implemented mesh shaders. There's no support for vertex shader. The vertex shader is hard-coded. It's just a square that draws this. But if you write a mesh shader, you can have your custom meshes that you generate. So this is an example. So what happens here is that I have a function which is the object stage. If you override the object stage, then you can have generate your own objects. This object grid here is the number of threads for the object. So this is 16 by 16, so there are 16 cubes. My objects are cubes. I compute different rotation with time. And then there's a mesh stage. The mesh stage is where you actually generate your triangle, right? So in the mesh stage in here, I've generated a cube. So I have the faces of the cube in here, and that's it. So I have also the number of threads for the mesh. So I have 2 times 2. So, well, the total number would be 16 times 2, 16 times 2, right? And then the final fragment shader, which in this case is just the color. And something I didn't mention is that there's no way in Mantis Shrimp to specify the resolution of the output or the color space or whatever. I figured out it was too many parameters because I wanted to control whether it's HDR, the color space, blah blah blah. So I thought it would be easier, since this is a mesh image diff tool originally. You want your output to be the same as the input usually. So I'm just using one input image here for to specify my output. So because this image is sRGB, the output is sRGB, but I also support wide RGB color space. For instance, if I drag and drop this one here, now the output is in display P3, which is wide RGB color space, and then the buffer changes to the texture changes to a 16-bit per channel RGBA texture. The actual display depends on your Mac, what it supports, but I'm using here BGRA 10 extended range. And yeah, and I also support HDR images. So this is an HDR image. You can see that here is in sRGB it looks like it's all white, but actually it's not. You can see, and I have a threshold here. There's the color of the sun there. I'm going to show you another example with mesh shaders. So by default, the mesh shader it creates like sprites. So, well, the object stage. So if you don't override the object stage, it's going to override like 2D sprites. And what I've done here, I overrode the mesh stage, and in the mesh stage I'm doing something like the typical effects like I showed earlier for the Genuary, right? So I have sign distance functions like the sign distance circle here to draw stuff, but instead of doing it in the fragment shader, I'm doing it in the mesh stage. So in the mesh stage I use my UV is gonna be like the sprite, like the position of this, right? So I'm doing all the effect, the same effect I would do in the fragment, I'm doing it in the mesh stage, so this rotation and stuff. And then in my fragment stage, I'm simply sampling this texture I have here to replace those sprites by these colors and textures, so it looks like old school. Old school using mesh shaders. So a complete over engineer, I don't know, but I think it's quite a clear example of how mesh shader works and how you can split threads to create a grid and stuff. Right, so that's Mantis Shrimp, and now I'm gonna show you Xcode and how Mantis Shrimp is created. So this is Mantis Shrimp code. It's not that complicated. It has a few rendering classes and it's written in SwiftUI. SwiftUI is a declarative way to create UIs. So this looks a bit long, but it's all declarative, so I think you can read quite easily from top to bottom. So for instance, I have a vertical stack here, there's a horizontal stack. In this horizontal stack, which is this thing, I have a toggle, which is this linear RGB button, color picker, then there's a slider here, etc. So it's quite straightforward. The only thing complicated here is because I'm using SwiftUI, the integration with Metal is a bit complicated. I had to create my own Metal view, which is this one. And this Metal view is just an interface. It's just to pass the data through, basically. So I'm passing all the data when you change something. For instance, if you drag and drop, an image, these things will be called. This is a lambda function defined here in place. Where you drop the image, well, first it makes sure there's some guards to make sure the image exists and all the stuff. It's not null, and then it calls set image in here, and then I call a delegate, and that calls my renderer set image. Well, my renderer is not that complicated, but I don't think I have time to explain everything in here, so I'm just gonna focus on some little things so you can have a picture of how this works. For instance, when you set the output here, what I do is I check for the format, for the pixel format of the output. As I said, I support many different formats, so I'm checking if it's linear RGB or not. I have some utility functions to convert to the different formats. For instance, if I have a grayscale image, then I set this to RU norm sRGB. So these formats, maybe you are familiar with this, but these do the automatic conversion. See, ordinary format with one 8-bit normalized and signed integer component with conversion between sRGB and linear space. So it does it automatically for you, so I don't have to write it in the shader. That's why I have all these weird conversions here. So I make sure I select the appropriate pixel format if I need automatic conversion, so it does it, etc. What else? And then how this thing works is I don't have a render graph. My render graph is just an array of plugins that are registered at the beginning, and they are executed in order, so maybe not very efficient, but because I don't have many things. My graphic plugin is just something that has a draw function and update buffers, and I have basically just a couple. So the output plugin is the final output, which does only the conversion between my texture to the output that you see on the screen, so the viewport. And I have Metal works with the states. You have to define the state at the beginning before you create the graph. So it's, well, similar to Vulkan or DirectX 12, so you may be familiar with that. So that's why I have so many render pipeline states in here, because I do it for the different combinations. If I have to apply the gamma, if not, if it's grayscale or not, because I have different pixel formats for all this. Also, I have for video, because when I record video, I have to actually do the gamma conversion in the shader, so that's why I have different pipelines for video. And then once your draw function is simply selecting the render pipeline state, depending on if it's linear or not, set the texture, and then call a draw. The draw is, I have a full screen quad, which is just 4 vertices, and that's it. So I have the vertex buffer, and then I call draw index primitives, and I just draw the triangular streaks. It's just 2 triangles. I have something similar for the mesh, for draw mesh. The draw mesh, that you have an object buffer, and then you call draw mesh threads with a number of threads, or like per object and per mesh. But I think it's quite straightforward, right? I think I like this. Metal is not very complicated in comparison to Vulkan, for instance, because many things, I mean, the defaults work more or less. You don't have to set up many of the things by yourself, because you are targeting a very limited set of platforms, and Vulkan have to support many platforms, and in comparison it's easier. Also, I don't have any complicated templating functions. I just have all my stuff on my shader template in strings, basically. So I have, this is the signature that I told you. So for instance, for the object stage, this is a signature, message stage, this is a signature. And if you read the manual, I think you can override this if you want to pass more stuff, but for instance, there's no way for you to pass an extra texture the way it's defined at the moment. Perhaps I could have like an array of textures, but I should redo the UI. At the moment, the UI is very simple, and I like it like that because it's just you drag and drop stuff into it. So let's do something interesting. Let's do a frame capture. I think it would be more clear if I do a frame capture. Let's open the mesh shader example, which I think is interesting. Right, so this is the mesh shader example. Ignore this drag and drop an MP3 file here, because this is something I haven't released. I've been working on some more strange features. If I have this, if I press the metal capture here, I can capture 1 frame, and let's inspect that. So I like how this looks. Very cool UI for frame capture in Xcode. So you can see I have my mesh plugin, which does all the drawing because there's no vertex shader in this case. So my draw mesh threads does all the drawing, and you have here the depth buffer, the color, blah. You can inspect the object stage in here. This is interesting. You can see it points to the shader. You can open it here. This is the final shader with the correct signature and all. And then you can click on the different objects. You can inspect them here. Also, you can also inspect the mesh stage. You can also see the fragment shader. So this is all the render pipeline. You can inspect the graphics data, which is what I passed to all the different stages. So you have the time variable, the scale. Actually, there's a touch variable, so you can touch. So you could do interactive things. You could maybe make a game with Mantis Shrimp. I don't know. The resolution, pixel size, and maybe there's something here. There's something wave data. This is what I mentioned because I'm making now the histogram for an MP3, but I'm not sure if this is going to be ever released, but that's something I have in there. And then you can continue the execution, and it works normally, and you can do another capture if you want. So yeah, that's Mantis Shrimp, and that's a very quick introduction to Swift and Metal. I think it is better you read any of the articles I've written. They're also in Medium. Well, since we are here, I'm going to show you this MP3 thing, and you can tell me if you are interested in this. Yeah, the problem I have, well, I have two issues. One is that it's not really real time. There's some delay, so I have to figure out what. But it says drag and drop an MP3 file here. So if I drag and drop this thing here, now you have access to this wave data. If I now that you have the MP3, you can click play on here, and then it starts playing the MP3. So one of the reasons, as I said, is kind of slow, and the second reason is I'm not sure if it's gonna pass the reviews, because I had an issue with the Apple reviewers last time, because I've added this this function to record a video, and they see this play button and they get confused. Although in Xcode it's also a play button to compile the code, but anyway, they haven't read the manual. They got confused because I wrote that you can record videos. They thought that you can do video playback, but my app doesn't do video playback. I had to write in big letters in the description, it doesn't do video playback, because they sent me a screenshot of what they were doing, and basically what they were trying to do is they grab a video from somewhere, and then they drag the video here, which gives you the path. This is exactly the same behavior of Xcode. If you drag a file into Xcode, you get the path, and then they click play, and it's a missing fragment shader. It gives you an error. Check the manual. And they were like, doesn't work, it doesn't work, please fix it. And I'm like, what do I need to fix? So very frustrating, a lot of back and forth. And I explained, I mean, Xcode behaves exactly the same. If you drag and drop, you get this, you click play, and you get like, it doesn't compile. So what do you expect? What do you want me to do? Anyway, so imagine now if I have this MP3 here, and there's another play button in here. I don't know, it's gonna blow their minds. So I'm not sure if I want to go through that, but well, I mean, it's not as painful as Microsoft Store or Google Play. Well, Google Play, they want your blood, and I don't know what they want anymore. Very frustrating. It can take months with Microsoft Store. In comparison, well, Apple is suffering, but maybe, I don't know. If you want this feature of the Wave MP3, let me know. Otherwise, I don't think it will be released. Maybe I'll just have it internally to create my, I don't know, my videos. That's all. Bye.
어떡하래 삼아